Good day to each and everyone. I hope you are feeling well. Before anything else, allow me to introduce myself. My name is Torres from BizIT 2B. In this video, we will be discussing data structures and algorithms in C programming. One of the algorithms that we will be discussing is the queue. Now, to understand queue, we must first imagine ourselves in a line, no? Let us imagine na ata sa linya na naatay gipalit na products. Now, the first person in the line gets to purchase first in the store. Obviously, kung kisay na sa una sa linya, mo ay una makapalit. And so on sa sunod sa linya. Kung kisay pinakalas sa linya, mo ay pinakalas makapalit sa store. So that is the logic of the queue algorithm. Kay kung basayon nimo ang queue, linya siya, linya. Now, one of the principles of queue is the FIFO principle or the FIFO principle. Now, let us discover what does it mean. The FIFO principle refers to first in, first out. Kaya ganina, meaning kung kinsay na sa una, mo ay una makagawas. And also, Q follows another rule or principle, namely the LILO, meaning the last in, last out principle. Kung kinsay pinakalas, mo ay pinakalasad mo gawas. Understand Q clearly, let us read one of the descriptions of a queue algorithm. A queue is a linear data structure that follows the FIFO principle, first in, first out. Unlike a stack algorithm, where the last item added is the first one processed, a queue is fair. It has two open ends, namely the rear or the tail. This is where the new data enters, and the front or the head. This is where the data lives. By the end of this video, we will understand exactly how this works, and we will write a complete C program to implement it. To make a queue functional, we rely on standard operations. Let's define them clearly before we write any code. So, I will be showing you an illustration on the logic of a queue. So to illustrate it clearly, we'll be using an array because an array is the best example when you are dealing with linear. Now, as you can see, we have our arrays here having 5 boxes, and the bottom of the boxes refers to the index of the array 0, 1, 2, 3, 4, lastly 4. Now, napansin ninyo, we have 2 arrows here, the front and the rear. So ganina na-mention ako, the queue has a front and a rear. So the front refers to the first element and the rear refers to the last element. Now, if ang array, if our queue is empty pa, our front and rear is positioned in the -1. Kay wa pa may sud ang atong array, so napala siya sa gawas, the -1. So front and rear. Now, if you want to add an element into the array, muna na siya ang itawag na NQ. Now, NQ adds an element to the rear of the queue. If the queue is already full, we hit a condition called overflow. So, ang tawag dahil sa kung mag-add kag element sa queue is NQ. Now, kung namatik mo sa description, it adds an element into the rear. So, if ang atong array is wala pa isod tapos mag-add tag element, our front and rear will be in the index 0 kay index 0 is the start of the array. So naana ang ato ang front o rear sa index 0. So ang ato value ana is 1. Next, if ganahan ka mag-add og value sa index 1, so our rear will go into the next index, which is the index 1, and the value number 2 will be in the queue. Ang front lang nato is mustay lang siya as is sa index 0 kay ang gamit sa front is para na siya sa kung naatay ibanan. Now ipagpuno ta ang ato molihok lang ana is ang rear, so ang last kay diba a queue is linya man nya kung magpuno biya or naitaw nga maabot ang mapunan lang kay ang nasa luyo muna yung logic sa queue. Now if you want to add another element na sad, so ang atong rear mato na siya sa index number 2 and ang value ana is number 3. Next, mag-add na sad ta ang rear will mo-add to na sad sa index number 4, which is the index number 3 I mean. Tapos ang iyahang value ana is 4, and lastly mag-add na sad ta ang ato rear kay maabot sa index number 4, tapos ang value niya is 5. Now if mag-add kuno ta og another value ang ato rear kay nana sa pinaka last index, kung mag-add pa tag value ana ang atong queue kay mahimo na kunong overflow kay wala na may remaining spaces for that additional value. So magka-overflow ang imong queue. Moto magka-overflow error. Now tima na ta sa NQ. Now if ganahan ka na kay i-remove sa queue, that is another function of a queue which is called the queue, meaning it removes an element from the front. If the queue is empty and we try to remove something, we hit underflow. So the queue removes an element. So ato front is nasa index 0 and ato rear or back is nasa index 4. If we want to remove one element, our front will be moved into the index 1 and the value in the index 0 will be removed, and di na sad siya mabutangan o throw because our front is in the index 1 na. That is one of the qualities of a queue. If you remove an value in a particular index, that index cannot be filled with another value na. So mawa na ang space for the index 0. So if we want to remove one value again, our front in the index 1 will move into index 2, next in the index 3, and lastly in index 4, which is the last index. Now if you want to remove again one value, our front and back will reset because if ang front kay mas dako or mas mulapas pa siya sa back or rear, ang atong Q is mo reset into -1. So ato front o ang back mo reset mo balik dito sa -1. Kay wala naman sulod ang ato ang Q. Now, our another example is atong front is in the index number 1 and our rear is in index number 1 also. Now, if you want to remove one element, our front will be in index number 2. And now, based sa ato ang conditions ganina na if mo labaw or mo lapas ang front sa back, meaning mo reset ang ato ang Q into -1 kay wala na isod ang ato ang Q. So mo pa na siya, mo underflow. That is one of the rules in Q. Now, there's another function in Q which is peak. Peak lets us look at an item at the front without removing it. So, reha ganina, ang ato front is in index 1. Tapos, ang iya value is 2. So, if mo gamit tag peak na function, ang iyahang i-return na nga value is 2. Okay? Iya i-return nga value is ang nasa front man. So, ang front is 2 man. Ang value kay 2. So, ang iya return value is 2. Lastly, this is the last two functions of Q, namely is full and is empty. Is full checks if the Q is full, no? If naatanan sulod ang index array. If full gani ang ato ang array, i-return niya nga value is true. Now, in SMT na sad, if ang atong Q is empty, i-return nga value is true. Simple as that. Additional function of a Q also is the size. If we call a size function in Q, it shows the number of size in a Q. So, example, ganina, dere, ang ato elements, number of elements is 5. No? 5 boxes. So, meaning our size here is 5. And now we're done with explaining the logic of a Q. Now let us proceed to the code example of using a Q algorithm. Step 1, setup and globals. So we will set up our headers first in C. First, we include our standard library and define a macro for our Q size. So let's define a variable size which is 5. Now let's initialize our variables integer array, namely items, which is the size is in size naa siya 5 size, and variable in front, let's initialize it into -1, and rear is equals to -1. As we discussed earlier, ang rear and ang front is initialized in -1 if wala pa tay Q. Step 2, the enqueue function. So let's create the enqueue function. Now the function to add items, we must first check if the queue is full. Now, mag-void enqueue ta, tapos our parameter here is the integer value. Now inside the function, we have the first have an if statement to check if ang queue is full. If rear is equals to size -1, then we will be printing queue is full. Okay, size -1 is the size of the number of index inside the array. So So if equal gani sila sa rear, meaning full ang Q. Else, kung dili full ang Q, so we'll be executing another if statement. If front is equals to -1, then we will be assigning front with 0 in the index 0. So meaning, our front kay naa siya sa 0 kay dili man full ang ato ang Q. Now, our rear is incremented inside. Tapos, let's assign the items in the rear with the corresponding value, and will be print inserted and pointed into the values in the queue. Now, magpadayon na siya dagan if dili full ang ato ang queue. If full gani ang ato queue, diha na musta pang iyahang pag and queue. Notice the logic. If rear equals to size -1, we cannot add more. If there is space, we increment rear and increment the value. Also, if this is the first item, we ensure front is set to 0. Step 3, the dequeue function. So let's define another function which is to dequeue. Now, in the dequeue function, we will having void dequeue, and we will be not returning any values. So, lang siya, no parameters. Now, if front is equals to -1, meaning ang front kena siya sa gawa sa array, so we'll be printing Q is empty because naman siya sa -1. Else, i-delete niya ang value nga naa sa front. Our front here will be incremented because para mo move ang front into the next index. If ang front is greater than the rear, i-reset ang front into rear into -1. So mo na ito condition ganina. If mula pa sa ang front sa rear, mo reset into -1. We check if it's empty first. If not, we remove the item conceptually by moving the front index forward. If front passes rear, the queue is empty, so we reset both to -1. Step 4, which is the final step, is to create a main function. So let's finally test it. Now let's define our int main. Then add our NQ here is the value is 10, another NQ 20, another NQ 30. So we'll be adding 3 elements into the array items. Now let's remove an element. So dequeue, let's just call the function dequeue. Now if we verify, let's print our remaining values. So if we print from index is at front, print rear index is at rear. So this code will determine the values of the corresponding index. Kausa naman siya nag-remove sa element, so usa lang ang ma-remove, which is 10. So ang atong value ani is 20 at index 1 and 30 at index 2. That's it for the example of using C in Q. Lastly, we're almost done with the Q. Let us have another information about the Q. No? So the time complexity, both NQ and DQ are at 0, 1, meaning they are constant time operation. It doesn't matter if the queue has 5 items or 5 million, the operation speed is the same kay nagagadra ang front sa rear, ang rear sa front. The space complexity, this is in 0 n, where n is the size of the array. Queues are used everywhere, from printers pooling to CPU task scheduling. Queues is used in various ways, such as in video games, no? Kung magduwa tag ML or COD-M or any other video games, when it comes to matchmaking, no? They are using the queue algorithm. Kay kung kinsay una maka-start, masay una maka-duwa. That's the logic of the queue system and the matchmaking system of video games. Now, we're done with the discussion about the queue. I hope you understand everything and linora para ninyo. That will be all. Thank you for listening and thank you for watching. Have a great day.